Hi everyone, today we are going to look at sorting algorithm. The three basic sorting algorithm is bubble sort, selection sort, and insertion sort. No matter what, you need to learn from these three first. Wherever school you go study, right, you will learn these three basic algorithm. You need to know ideally how the sorting work before you can code it out. Because if you code it out without knowing what you are doing, then it's pointless, right? You cannot memorizing the code. But if you know what is the step to sort the array, then you will know how to write out the code, okay? So let's look at the bubble sort. Let's say we have our number is not sorted at all, okay? Say 4, 3, 2, 1 of a bubble sort. If you start from 4, 3, 2, 1, right? How do the sorting algorithm for bubble sort work? So 4 would first compare with 3. Is it larger? If it's larger, right? Then it becomes 3, 4, 2, 1, okay? Then we're going to compare with the next number. Is 4 larger than 2? Yes. If it's larger, right, then we write 3, 2, 4, 1, okay? And then we are going to compare 4 with 1, okay? Is 4 larger than 1? If it is, then it will swap again. So it becomes 3, 2, 1, 4. So what I would advise you, right, you would better, right, write a, if you are using Java, write a swapping algorithm, okay? Write a swap. So your code looks smaller and also more neat. Okay, so the second round, right, what you do is, if you want to look at the optimized algorithm, right, what did you notice? You notice that the largest number is always at the back. So if you notice the largest number is at the back, right, you can reduce the count, reduce the number of cycle. Initially, right, we look at 4 number. We are swapping 4 times, okay? We loop it until the end. So if we want to reduce the cycle, right, then we minus 1. Okay, if you minus 1, then we are going to look at this 3 number only. Let's look at this 3 number, 3, 2, 1, 4. Then we are going to repeat from the first index again, okay? If you repeat from first index again, is 3 larger than 2? If 3 is larger than 2, right, then we swap it 2, 3, 1, 4. Is 3 larger than 1? If 3 is larger than 1, right, then it becomes 2, 1, 3, 4. And then it's 3. Oh, no need. We can ignore this, okay? Because just now, right, we already ignored this one. So up until here, then we stop. So what do you notice here? In here is already sorted, right? The largest is 4, then followed by 3. So what we do is, we decrease again. We decrease the number of time we need to look at. So now what is needed is only sorting these 2, remaining these 2. Example, right? So say if you have you need to allocate something. Say you call this as pass count, okay? Pass count. So initially your pass count is 1, okay? Your pass count is equal to 1. In here, right, when you finish sorting it, right, so you add it, so your pass count becomes 2. When you add your pass count is equal to 2, right, your for loop condition will this minus this pass count. Your for loop condition minus this pass count, so we only look at this 2 number. So let's look at this 2, 1, 3, 4. So let's look at this one. We can ignore it because it's already sorted. Is 2 is larger than 1? Is 2 is larger than 1, right? So what we do is we swap it 2, 1, 3, 4. Then we increase the pass count again. Okay, so pass count now is 3. Pass count is 3. When pass count is 3, right, our for loop condition will minus this pass count. So remaining is 1. So if it's 1, right, we already sorted it. This is how the bubble sort works. Now let's look at selection sort. How do selection sort work? We use back 4, 3, 2, 1, okay? So in a selection sort, right, you have an index, okay? You have an index. You want to know what is the current index. The idea of selection sort is you want to move the smallest number into the front of that index, okay? So what selection sort do is you need a marker of the current index and you want to find smallest number, okay? You want to find the smallest number and put it to this index. What do I mean by that? Let's look at number 4, okay? When you look at 4, right, you compare with 3. Is 3 is smaller than 4? If 3 is smaller than 4, right? So let's say you mark it, okay? You mark it. When you mark it, right, then you look at 3 compared with 2. Is 2 is smaller than 3? Yes, if 2 is smaller than 3, right, then you mark it again. If 1 is smaller than 2, if 1 is smaller than 2, right, then what you do is, you're going to here. If it's the end, right, swap it to the front. So it becomes 1, 4, 3, 2, okay? Let's look at second cycle. Second cycle, right, from this position, you move this index to here, okay? We are looking at this index now. When we look at this index, right, we check is 2 smaller than 3. If 2 is smaller than 3, right, then we add our marker. This is the smallest number now, okay? So we check is 4 smaller than 2. If it's not smaller, right, then we swap these 2, okay? So it becomes 2, 3. So here is 1 and 4, okay? So after we swap it, right, we need to move this index. We are checking here, third position, okay? We are checking the third position. When you check the third position, right, let's look at 4. Is 4 smaller than 3? No, right? So this cycle is complete. If this example is too small, right, let's increase the complexity, 5 digit. So let's say 5, 3, 2, 4, 1, okay? 5, 3, 2, 4, 1. So initially, right, we are going to check the first element in the array, okay? We check the first element. So we mark it 5 and 3. Is 5 vs 3. Is 3 the smallest number? If it is, right, then we are going to mark the temporary marker, okay? Put the temporary marker in here, 3. So let's look at 2. When we shift to here, right, is 2 smaller than 3? If it is, right, then we shift the marker, okay? We shift the marker, become here. Then we check, is 4 smaller than 2? No. If it's not smaller, right, we move to the back again. Is 1 smaller than 2? If 1 is smaller than 2, right, then we put the marker here. Put the marker here, okay? When it reaches the end, right, we are going to swap 1 and 5, okay? We will swap 1 and 5. And you need to keep in mind, selection sort is not a stable sort. What do stable sort mean? Example, if you have a table, right? If you have like, example, ID, and then you have a data, right? So say this name. So let's say the first name is Eric, and the second name is Apple. So if the ID is 1, right, and the Apple is 1, right, when you perform a selection sort, right, no matter what, right, because selection sort is using the index. Because selection sort is using the index, right, so no matter what, even, right, even if the ID, we are sorting by ID, right, if we are sorting by ID, we cannot confirm. We cannot confirm if this is in sorted order. So example, if you, this is your, say, a data sheet, you key in Eric first, then only you key in Apple. However, because you perform a selection sort, then what may occur is the Apple may move upward, okay? So the Apple may switch here and the Eric may shift here because of the property of selection sort. When you look at the pseudocode of selection sort, right, you will get what I mean. Because no matter what, we will swap the index even if it's sorted. That's why selection sort is not stable. So, example, if you want to return the order, right, you key in Eric first, then only you key in Apple. Because of you swap the list, then it become not order already. So let's resume here, okay? When we notice this is the smallest, right, so we put it in the front. If this become 1, this become 5. And then we remain with 3, 2, 4. And then we move our index position to here. We move the index position to here, right? We need to compare. Is 2 is smaller than 3? Yes. If 2 is smaller than 3, right, then we put a marker. Is 4 smaller than 2? 4 is not smaller than 2, right? Is 5 smaller than 2? No, it's not smaller, right? So what we do is, we're going to swap, okay? So it becomes 2, 3. So we are remaining with 1, 4, 5. So we are going to move this index to here, okay? Move the index to here. So we move this index to here, right? Let's see, is 4 smaller than 3? No. If 4 is not smaller than 3, right, then let's look at, is 5 smaller than 3? If 5 is not smaller than 3, right, then we don't do anything. Okay, the funny thing about selection sort, right, no matter what in the end of the cycle, right, even if this is not changed, right, you are going to assign this number to a temp variable, and then you are going to assign the temp variable back to this third element. So example, right, so if we set temp is equal to array, okay, array 2, and then, right, we are going to assign array 2 is equal to temp. This is the ironic thing about selection sort. Okay, and this is not yet end. We are not end yet. Actually, if you follow the selection sort code, right, you're going to check number 4 again. It's going to shift this index position to here. So if 4 is smaller than 5, smallest, right, then it's okay. Then we are going to shift this index cursor to here. So when you shift to here, right, then it's the end. It's what selection sort is doing. Finally, right, let's look at the insertion sort. Insertion sort is my most favorite algorithm. However, insertion sort is not the fastest also. If you want the fastest, right, in later chapter you will see an improved version of insertion sort. The improved version of log 2n, if I'm not mistaken. I forgot already. Square root log n or log 2n, I forgot. But we will look at that in the later chapter, okay? Now you are going to focus on insertion sort only. Let's look at how do insertion sort work. The idea to do an insertion sort, right, we need a marker, but this marker is a bit special. Let's look at 4, 3, 2, 1, right? In each time comparing, right, your lecture slide is using index 1 as marker. But for my own code, right, my own written one, I'm using index 0. If you use index 0, right, then you need to add 1. But you can follow your lecture slide 1. Your lecture slide is using index 1. If you are using index 1, then you minus 1. So let me explain what do I mean by comparing in pair. When you're starting from index 1, right, when you're starting from index 1, you're going to compare in pair. What is in pair? What do you mean? In pair, right, meaning you're going to compare these two, okay? Is 3 is smaller than 4? Is 3 is smaller than 4? If it is, then we are going to swap it. So it becomes 3, 4, 2, 1, okay? If there is a swapping needed, we need to keep swap until index 0. When it reaches index 0, only then we can move the marker to the next position. When we move the marker to the next position, right, so the marker will be in here. When the marker is in here, right, then we need to compare in pair again. When we compare in pair, right, let's look at 2 and 4. Is 2 is smaller than 4? If it is, right. So what we need to do is, let's say we swap the 4, okay? We swap the 4 into this position, and then our 2 is in this position. Let's put this marker. This marker is in here. This marker never changed, okay? The marker is still in this position. However, right, your 2 and 3 not yet swapped, right? Your 2 is not sorted yet. You still need to compare these two in pair. This is what I mean in pair meaning. So you are going to look at these two, okay? You're going to look at these two. Is 2 is smaller than 3? If it is, right, then we swap it, okay? So let's write it down. 2 is in here, and then our 3 is in here. And then let's write the 4 back. When the 2 has reached index 0, right, then only we can increase the marker to the next position, okay? So let's put our marker to the next position. When our marker is in the next position, right, we need to compare it in pair again. Let's look, compare it in pair. Is 1 is smaller than 4? Yes, right. If 1 is smaller than 4, then what we need to do is, we need to swap it. So our 4 would be in here. Our marker still remain the same, okay? And then, right, let's put our 1 in here, okay? So 2 and 3 is in here. And then we need to compare in pair again. Let's look at this position. If 1 is smaller than 3, if 1 is smaller than 3, right? Then we are going to swap these two, okay? We swap these two. 1 and 3 is in here, okay? So let's write it back 4. 4 is in here, okay? This is the marker. Then the 2 is in here. And then, right, we need to move it, check it in pair again until you reach index 0. So like this, right? So it becomes 1, 2, 3, 4. Okay, the marker still remains here. So until here, right? Only then it finished